Again, a reasonably basic skill, but complexity will escalate as you travel through the chapter. What we've got here in brackets, this is what we call the fundamental theorem of calculus, okay? Because I've said, within calculus there's two parts of it. There's differential calculus, which is our chapter 1 and 2, our test 1 and 2, and then there's integral calculus, which is just going back the other way. But we just separate them neatly into integration and calculus. This is the fundamental theorem of calculus, okay? So if we want to find what we've got here, we've performed what we call indefinite integrals. That's when they don't have any numbers there. As soon as we introduce numbers to them, they're what's called a definite integral because they're going to take a value. And its physical significance I'll perhaps explain on Friday, but for now we're just going to crunch some numbers again. So if we're going to find the integral of 0 to 2 of x squared, what we're going to do is we're going to use these square brackets, and we go, what is the integral of x squared first? Well, that's going to be x to the 3 on top of 3. And the boundary over which we're performing that is from 0 to 2. Isn't it? Okay, we're going the integral from 0 to 2 of x squared, and so that's the boundary over which it's being performed. And so you can see here we're just following on from here. So therefore, if you're going to evaluate this, it's going to be 2 to the power of 3 on 3. Take 0 to the power of 3 on 3. Right? F of b, take away f of a. You put b in the antiderivative. So we put 2 in the antiderivative, and then we put 0 in the antiderivative, and we're doing f of b, take f of a. And then we just simplify that, 8 on 3. Okay, that's it. So we'll do b. So we go square brackets, we go, what's the integral of e to the power of 2x? That's going to be 1 on 2 e to the 2x, from 0 to ln 3. Okay, then we substitute in the values of b and a. It's going to be half e to the 2 ln 3, take half e to the 0.
How is it half in front for the e to the?
So the integral of e to the kx, this is the rule, is 1 on k e to the kx.
Oh, yeah.
Yeah. So if it's e to the 2x, it's 1 on 2 e to the 2x. Very good. And then here, let's simplify that a bit. Alright, I think the best way to think about that, this is going to take a number of steps here. The best way to think about that is if you have a ln n, or n ln a, we tend to write it as that, sorry. N ln a, you can write that as ln of a to the power of n. So what you've got here is ln of 3 to the power of 2. So that's ln of 3 squared, which is ln of 9. So we've got half e to the ln of 9. Now e to the 0 is just 1, so we've got to take away half here. Okay, and then you have e to the ln x is equal to x. So when we have here e to the ln 9, that simplifies to be 9. So we've got half times 9, take a half. Alright? Now you can break this down further, but look at this, we've got 9 lots of half, and we're taking away 1 lot of half, we're going to have 8 lots of half, which is 4. Okay, or you can go, well, it's 9 on 2, take 1 on 2, it's 8 on 2, which is 4. There's lots of ways you can think about that. So that's our process. So we go to 4G definite integrals. Definitely going to do 4G today.
Definitely?
Definitely.